Okay, Walker. Today we're at journal page 66, graphing logarithmic functions. Example 1. Identify the transformations of the graph of f of x equals log base 2 of x that produce the graph of the given function g of x. Then select the graph of g of x on the same coordinate plane as the graph of f of x by using the transformations to the asymptote x equals 0, and to the reference points 1, 0, and 2, 1. Also enter the domain and range of g of x using set notation, round your answer to the nearest hundreds. Okay, so g of x equals negative 3 log base 2 of x plus 5 plus 3. Step 1. The translation of 5 units to the left affects only the x coordinates of the points on the graph of g of x, while the vertical stretch by a factor of 3, the reflection across the x-axis, and the translation of 3 units up affect only the y coordinates. Step 2. Complete the table. Okay, so when f of x equals log base 2 of x, the asymptotes x equals 0, the reference points are 1, 0, and 2, 1. When g of x equals negative 3 log base 2 of x plus 5 plus 3, the asymptote is x equals negative 5, and the reference point 1 minus 5 is negative 4, and negative 3 times 0 is 0 plus 3 is 3. Okay, 2 minus 5 is negative 3. Negative 3 times 1 is negative 3 plus 3 is 0. All right, let's go on to the next step. All right, step 3. Step 3. The domain of g of x is x such that x is greater than negative 5. Step 4. The range of g of x is y such that negative infinity is less than y less than infinity. Step 5. Graph g of x equals negative 3 log base 2 of x plus 5 plus 3. So the first thing we want to do is graph the vertical asymptote at x equals negative 5. Okay. All right, now we're going to go to our calculator. We're going to go to on, new document, no, add graph, and we're going to type in negative 3, and then we'll do control log base 2 of x plus 5 plus 3. Okay, and then we're going to do control T, and we know at negative 5 there's an asymptote, so we can use the point negative 4, 3, negative 3, 0, negative 1, negative 3, and 3, negative 6. All right, so those are the points that we have graphed. All right, go ahead and finish your graph. All right, now let's move on to the next example. All right. Example 2, identify the transformations of the graph of f of x equals natural log of x that produce the graph of the given function g of x. Then select the graph of g of x on the same coordinate plane as the graph of f of x by using the transformations to the asymptote x equals 0 and to the reference point 1, 0, and e, 1. Also enter the domain and range of g of x using set notation, round your answer to the nearest hundreds. G of x equals 1/5 natural log of x plus 4 minus 3. Step 1. The translation of 4 units to the left affects only the x coordinates of the points of the graph of g of x, while the vertical compression of the factor of 1/5 and the translation of 3 units down affect only the y coordinates. Step 2. Complete the table. Alright, so when f of x equals natural log of x, the asymptote is x equals 0, the reference point is 1, 0, and the other reference point is e, 1. When g of x equals 1/5 natural log of x plus 4 minus 3, the asymptote is x equals negative 4. And so now our reference point is 1 minus 4 is negative 3. And 1/5 times 0 is 0 minus 3 is negative 3. Now we have e minus 4, so to calculate that, we need to go to on, new document, no, add calculator, and then we're going to find the e button, which is right here, get rid of the exponent portion, and then minus 4, you get negative 1.28, let's just say negative 1.3. Okay, and then we have 1/5 times 1, which is 1/5 minus 3. So again, we can use our calculator. 1 divided by 5 minus 3 is that, but let's press Control Enter, negative 2.8. Okay? All right, let's move on to step 3. All right, step 3, the domain of g of x is x such that x is greater than negative 4. Step 4, the range of g of x is y such that negative infinity is less than y less than infinity. Step 5, graph g of x equals 1/5 natural log of x plus 4 minus 3. All right, so first off, we know we have an asymptote at negative 4, or vertical asymptote at negative 4, so let's go ahead and graph that first. All right, and so now we're going to go to on, new document, no, add graph, and we're going to do control divide 1 divided by 5, parentheses, natural log, which is right here, control there, x plus 4 minus 3. We're going to press control enter, control T, and let's look for points that we can use. So we know we have an asymptote there, negative 4. So negative 3 is a good point. And let's see if we have any other. Doesn't look like we have any perfect decimals, so we're just going to have to use what we have. So let's do 0, negative 2.7. Again, these are just going to have to be approximated points. And 5, negative 2.5. All right, so when you don't get the best points, you just use points that you can approximate. And we know that curve is going like that. All right, go ahead and finish up the graph. All right, now that completed, let's take a look at example 3. Identify the transformations of the graph of f of x equals log base 2 of x that produce the graph of the given function g of x. Then select the graph of g of x on the same coordinate plane as the graph of f of x by using the transformations to asymptote x equals 0 and to reference points 1, 0, and 10, 1. Also enter the domain and range of g of x using set notation. Round your answer to the nearest hundreds. G of x equals 5 log of x minus 3 minus 2, and I should say log base 2. Okay. Step 1. The translation of 3 units to the right affects only the x coordinates of the points on the graph of g of x, while the vertical stretch by a factor of 5 and the translation of 2 units down affect only the y coordinates. Okay. Complete the table. When f of x equals log base 2 of x, the asymptote is x equals 0. Oh, I'm sorry. No, this is log base 10. This should be log base 10 right here. They switch it up on you in the problem, so be careful of that. So this is log base 10. When they don't put a log, it's assumed base 10. Okay, so this is log base 10. Okay, so be careful not to make the mistake I made and think it's just base 2, but if they don't put a base, then we assume it's 10. Okay, All right, so the asymptote is x equals 0, the reference point is 1, 0, and the reference point is 10, 1. Okay? When g of x equals 5 log base 10 of x minus 3 minus 2, the asymptote is x equals 3. So now we have 1 plus 3 is 4. 5 times 0 is 0 minus 2 is negative 2. 10 plus 3 is 13. 5 times 1 is 5 minus 2 is 3. All right, go ahead and complete the table. All right, now the table is completed. Let's take a look at the graph. Okay, step 3, the domain of g of x is x such that x is greater than 3. Step 4, the range of g of x is y such that negative infinity is less than y less than infinity. Step 5, graph g of x equals 5 log. Notice, they're going to put this on the assignment, and this is where I made a mistake. It's not, if the base isn't there, we don't assume it's 2, we assume it's 10. So this is the base 10 of x minus 3 minus 2. Okay? All right, so let's graph that. So we're going to go to on, new document, no, add graph. So we have 5 times control log base 10 of x minus 3 minus 2. Press enter. Now, let me take a step back before we get to points. We know that it's x is greater than 3, so we have an asymptote at x equals 3. So let's graph that first. Almost graph without graphing the asymptote first, but you really want to graph the asymptote first. So x equals 3. You can do it the other way and graph and then do the asymptote, but I really recommend graphing the asymptote first. Okay. All right, now we have the asymptote graphed. Now let's get the points. Control T, and you can see that with the asymptote was at 3, we have the point 4, negative 2. And it looks like this might be another one where, nope, 13, 3. So the problem with that is we have 9, 10, 11, 13 would be off the page here. So we're going to need to come back and use point 8. That's about 1.5. So that's a good point. So we can do 8, 1.5. Okay. And those 2 points are enough because we know that it falls along the asymptote. It's going to go up through there. All right, go ahead and finish up the graph. All right, now your graph is complete. Let's take a look at the last example. Okay, example 4. Identify the transformations of the graph of f of x equals natural log of x that produce the graph of the given function g of x. Then select the graph g of x on the same coordinate plane as the graph of f of x by using the transformations to the asymptote x equals 0 and to the reference points 1, 0, and e, 1. Also into the domain and range of g of x using set notation, round your answer to the nearest hundreds. So we have g of x equals negative 5 natural log of x minus 4 plus 2. Step 1. The translation of 4 units to the right affects only the x coordinates of the points in the graph of g of x, while the vertical stretch by a factor of 5, a reflection across the x-axis, and the translation of 2 units up affect only the y coordinates. Complete the table. F of x equals natural log of x. The asymptote is x equals 0. The reference points are 1, 0, and e, 1. When g of x equals negative 5 times the natural log of x minus 4 plus 2, you have a vertical asymptote at x equals 4, and the reference point 1 plus 4 is 5. Negative 5 times 0 is 0 plus 2 is 2. E plus 4, we're going to need to use our calculator, so we're going to go to on, new document, no, add calculator. We're going to press Control E. We're going to, not Control E, press the E. We're going to delete the exponent and then plus 4. So that's 6.7. Okay, and then negative 5 times 1 is negative 5 plus 2 is negative 3. All right, go ahead and complete the table. All right, now the table's completed. Let's take a look at step 3. Oh, I'm sorry. The domain of g of x is x such that x is greater than 4. Step 4. The range of g of x is y such that negative infinity is less than y less than infinity. Step 5. Graph g of x equals negative 5 natural log of x minus 4 plus 2. Alright, so let's go ahead and graph that. So we go to on, new document, no, add graph. So then that's negative 5 natural log of x minus 4 plus 2. Alright, we have that, but let's take a step back before we get those points. We want to graph the asymptote, which we know if it domain is x is greater than 4, we have a vertical asymptote at x equals 4. So let's graph that. Okay, so we have vertical asymptote at x equals 4. Now let's go ahead and graph the points. So control T. 5, 2 is a good point. And then looks like we're not going to have any good whole number of points. So 7, negative 3.49 is negative 3.5. So we can graph that negative 7, negative 3.5. Okay, and I don't think there are any other good points. Nope. So those are going to have to be good enough. All right, so go ahead and finish up the graph. And I know I said this was the last example, but I forgot there is one last example. So let's go over that. So this was the second to last example. All right. Example 5. Prove that natural log or log of 1 divided by b of x equals negative log base b of x for any positive values of b not equal to 1. Step 1. Begin the proof by setting log 1 divided by b of x equal to m. So we have that log of 1 divided by b equals m. Step 2. Rewrite the equation of log of 1 divided by b equals m in exponential form. The exponential form of log of 1 divided by b equals m is x equals 1 divided by b to the m power. Step 3. When x equals 1 divided by b to the m, we can write that as b to the negative 1 times m, which simplifies to b to the negative m. Step 4. Therefore, in logarithmic form, the equation b to the negative m equals x is log base b of x equals negative m, or negative log of b of x equals m. By the transitive property of equality, log of 1 divided by b of x equals negative log of b of x. All right, if you would go and finish that up and have a wonderful Wildcat day.